Okay, so we are to the final lesson in this half of Unit 3. I split Unit 3 into two separate units because I feel like there's different content and I wanted to separate that. So what we're going to work on today is solving linear systems in three variables. So here I have the steps to solving these, and these systems have variables x, y, and z. So what you want to do is you want to make sure that your system has each equation with x, y, and z all on the same side of the equation. All on the same side. So all on the left-hand side, I would say. You choose a variable to eliminate, and then you choose only two of the three equations to eliminate that variable. And I'll talk about that. Select a different variable or different set of two equations and eliminate the same variable. So if you chose to eliminate x with two equations, choose two different equations and eliminate x from those. Then you have a two-variable system, and then you can solve that system using elimination. So I'm going to jump right into that because the last three steps there are mostly repeating. So if I look at this system, what immediately catches my eye is that in the equations 2 and 3, think of this as 1, 2, and 3. In equations 2 and 3, the x's match up actually. So for this one, I'm not going to rewrite it. What I'm going to do is I'm going to show adding these equations together right here. So x automatically eliminates there. I get 8y plus 10z equals 74. So I decided to eliminate x. So what I am going to do is I'm going to take equations 1 and 2. So the first equation, and then the second equation, I'm going to think about what do I have to multiply by that second equation to get the x's to match up. I'm going to multiply the second equation by 3. So the second equation becomes negative 3x plus 15y plus 36z equals 73 times 3, which is 219. And then I add those together, and I should see that 3x and negative 3x cancel. So this becomes 13y plus 40z equals 239. So you see how I have a two variable system there. So I can line things up in that two variable system. I'm going to do that in a different color, maybe. So I'll have 8y plus 10z equals 74, and then 13y plus 40z equals 239. So I'm lining those up. Then I'm going to just solve that system like we'd been solving systems before. It's going to be easier to get z's to match up. So I'm going to multiply the top by negative 4 to get 10z and 40z to match up. So the system becomes negative 32y minus 40z equals 74 times 4, negative 296. And then you got 13y plus 40z equals 239. So when I add those together, the z's cancel. And then negative 32 plus 13. It's going to be negative 19y. And then negative 296 plus 239 is going to be negative 57. Divide both sides by negative 19. I get y is 3. So that's a lot of work just to get y. But now it becomes easier because I can find z by plugging into one of these two blue equations here, one of these two variable equations. So I'm going to plug it into the top one, 8y plus 10z. So that would be plugging in for y is 3. It would be 24 plus 10 z equals 74. So then 10z equals 50, z equals 5. So there's two of them. Now we still got to find x. So I'm going to go all the way back into one of my very original equations. I'd plug into equations 1 or 2 or 3, I guess. So let's plug into equation 3. This would be x plus 9 minus 10, since y is 3, z is 2. And that equals 1. So x minus 1 equals 1. And then x equals 2. So my last way I'd show this solution, okay? The last way I'd show this solution is as a 3-point or a 3-value point, ordered triple, you'd call it. 2, 3, 5, okay? And that was one example that took me about 6 minutes to explain. So this lesson requires you to be patient. It requires you to really show your steps and try to be as organized as you can. So just try this guided practice, pause the video, take your time, and then kind of check in when I go over my solutions to this system. All right, so this guided practice, there's a lot going on. So what I want to explain is how I started. I started by looking at equations 2 and 3 because they have negative y and y. So in my first step right here, this is where I eliminated y because all I had to do was add them together. I got x minus 5z is negative 8. So then I chose to eliminate y using two other equations. The next time, these two equations up here, I kept equation 1 the same. I multiplied equation, and I'll draw a line for that. I multiplied equation 3 by 3 to get the y's to eliminate. So I got an xz equation and an xz equation, and I eliminated right here. I eliminated x by multiplying the second equation by 2. And I broke that all down. I got z as 1. Once I get z as 1, my job becomes easier because then I took z being 1 and I substituted that in to x minus 5z is negative 8. I found out x, and then I substituted x and z into equation 1, and that's on this right-hand side, where I substituted all of that in, and I solved for y, and I got y is 4. So it's a process. It's a set of steps. But once you get that first variable solved for, the rest of them become much, much easier. Okay? So I am going to move to the next page. I am going to cover, I'm going to cover the next example, I think, because there are, I'm sorry, I'm kind of skipping around here, but I'm going to cover the next example. I'm going to show you what it looks like to have a variable with no solutions. And then I actually want you to try the next example 3 on your own. So like guided practice for example 3. So in this next example, it's about understanding how equations match up. And you could attack this in a lot of different ways. But sometimes it's almost like when you play chess. If you've ever played chess, it's looking a few steps ahead or looking a little bit deeper. So if I'm just looking at this, like I'm solving like I normally would, let's just look at y would be easy to eliminate, I think, because equation 1 and equation 3, you have 4y and negative 4y. So I have 2x plus 4y plus 10z equals 14. And in the bottom I have 3x minus 4y minus 3z equals 15. So y naturally cancels there. I've got 5x plus 7z equals, and this is 29. okay? So in my next step, I'll do that in blue just to kind of show the next step. But in my next step, I would look at using equations 2 and 3 because I have 2y and negative 4y. So I would multiply equation 2 and multiply that all by 2. So equation 2 would become 2x plus 4y plus 10z equals negative 8. And then equation 3 would remain the same. So y's will eliminate. I've got 5x plus 7z equals 7. So when you look at this, if I'm going to go to solving this system of two equations in two variables, 5x plus 7z equals 29. And if I'm going to eliminate, I would really just multiply one of the equations by negative 1. Or you could think about just subtracting everything, right? I could change the sign of all these. Negative 5, negative 7, negative 7. When I do that, we'll notice these eliminate, so this side of the equation becomes 0. This side of the equation becomes 22. That is not true. It results in a not true equation. So I would say that that system has no solutions. It has no solutions. It creates a false equation, meaning it has no solutions. So you can still solve these normally, but this cuts out a lot of the work if we are able to eliminate smartly. So in example 3, try it, pause the video, work through it, and then check your answers with me once you're ready. Okay, so for this example, hopefully it's kind of clear when you look at this system that y would be, in my opinion, the easiest to eliminate because literally every coefficient on y is 2, whether it's positive or negative. So my first step, I took equations 2 and 3 and I eliminated y, and I got 8x plus 16z equals 24. And then in my second step, I used equations 1 and 2 to eliminate y, and I got 6x plus 12z is 18. So when I went to eliminate that, I just noticed 8x and 6x are both factors of 24. So I multiplied the top equation by 3 and the bottom one by negative 4. And it just so happened that everything basically matched up, meaning everything eliminated, meaning I got 0 equals 0, which means infinite solutions. Now, infinite solutions doesn't only happen when I get 0 equals 0. If I do this and I get something like 7 equals 7, that would also mean infinite solutions. So don't be fooled thinking it's always just 0 equals 0. Sometimes it happens a little bit differently. But if everything eliminates and you get a true equation, that means infinite solutions. If everything eliminates and you get a false equation, that means no solutions. If you get x equals a number, that means you keep going and you try to find the other parts of the solution. Okay, so what I'd like you to do next, if you want, try example 4. Really, example 4, I'm not going to explain the solution. I'm just going to show you the answer. So I'm going to show my work, but I'm not going to really explain. The thing I'll show you here is you don't really need to use substitution just because it says so, all right? You use the method that works best for you. To make this the way we want it, I would rewrite this equation where I would subtract y from both sides. So this equation would be really x minus y plus z equals 0. So from the beginning, that's getting it in that standard form. So then you can kind of see maybe how things line up and you can solve. So I'm going to let you do that. I'm going to show my solution on the screen, and then I'll let you move on to the practice. Okay, so for this example, I showed my first step in red, my second step in blue, my third step in green, and then all my substituting in black. So I eliminated y to get a system with x and z. I solved that system, found out x, substituted into one of these two variable equations, and then I had x and z, and I plugged into one of my 3 variable equations to find out what y was. So if you want to take a minute to check it out, if you have any questions, this is a big, complex, I think, lesson. So it's good for you to ask questions, okay? So when you're to the practice, don't hesitate to ask questions, because one wrong step, one negative sign missed, one fudge on a multiplication can throw you off for the rest of the problem. So it's important that you try to do your work on a separate sheet. You try and take as much space as you can, and you go through these slowly. So you can move on to the practice. Take your time with the practice. I'm going to try and be kind of accommodating and try not to give you too many of these problems. Try and focus on ones that I think will help you get better at this without hopefully overwhelming you.